Alright, what I'd like to do is kind of go over a little bit of overview of parabolas, and we're going to talk about a special type of parabola today. We're going to talk about a quadratic function, and a quadratic is just a special type of parabola. And what it means is it's going to have a degree of 2. That means the leading term is going to be to the second power. So usually when we're looking at a quadratic function, it is going to be in the form of, f of x equals ax squared plus bx plus c. Now this form is very helpful for a lot of times where we're working with finding the vertex from this form, or also using the quadratic formula.
Pardon the interruption. Again, just a reminder that at 1:30 there's going to be Pearson training in the Media Center. Please bring your laptop. Again, at 1:30 in the Media Center for Pearson training, please bring your laptop.
Okay, so here we have a quadratic function. This is what they generally term where a, b, and c are all any real numbers, or you can just think of a number. Now, what does a quadratic function look like? Well, the general name of what we call them is what we call parabolas, and pretty much what they are is just a U-shaped graph, and they either open upwards or they open downwards. All right, and 1, 2. Now there's a couple instances or important aspects. Actually, let me change this original graph just so I can show you when we're dealing with it. So let's make this graph. Let's have it come up to here, and let's do 1, 2, 3, 4, 5. Okay. So on a parabola, you can see that they infinitely go to the left and right as your domain, but they either go in one direction or the other direction as far as up or down. Now, one thing was we're dealing with a parabola. There's a couple special features about a parabola. First thing are these 2 points that I made. All right, and what these 2 points represent are what we call a vertex. So the vertex is either the bottom, the lowest point of a parabola, or the top or the highest point of a parabola. So here, my point is -3, comma, actually, let me write it below here. It's -3, comma 0. And over here, I have my parabola is at 2, comma 4. All right? Now, so those are your vertexes. Those are at the bottom or the top of your parabola. And I'm going to show you algebraically how to figure that out. But the next thing we have to that is also helpful to know is that parabolas or quadratic functions are going to be symmetrical to an axis of symmetry. And one thing you can notice about the axis of symmetry is your axis of symmetry runs through your vertex. So it runs through the x-coordinate of your parabola. So you can see both here, the axis of symmetry runs through +2, and here it runs through a -3. So it's very important for you to understand that every parabola is going to have an axis of symmetry, and also that axis of symmetry is going to run through the vertex. So let's take a look at, let's see what else I want to cover. Let's take a look at then, from this form, how we are going to determine if, first of all, if the graph opens upwards or down. So if a in a quadratic form is greater than 0, my graph is going to open up. So therefore, this one, I don't know what the formula, what the quadratic equation is, but since this opens up, I know that a, which would be the number or the coefficient of my x squared, is going to be greater than 0. And if a is less than 0, then my graph is going to open down. All right. Now, the last thing that we want to go through is working with this is also how can we determine if we're given a quadratic function, how can we determine what the axis of symmetry is or what the vertex is? Well, fortunately for us, we have a formula to figure that out. Define the axis of symmetry for any parabola. For any parabola. Oh, polynomial. I get what I was saying. Overview of parabolas, overview of polynomial, quadratic polynomials. I got it. I originally said here's an overview of parabola, a special type of parabola. Well, all parabolas are quadratic, so my mistake. I misspoke earlier. So, anyways, define the vertex. what we need to do is, I need to take the opposite of b over 2a. So that is going to tell us the axis of symmetry. So you take your opposite of your b and divide it by 2 times a. Then, once I've figured out my axis of symmetry, that's the same thing as my x-coordinate of my vertex, correct? Right? Remember, the axis of symmetry runs through your x-coordinate, or through the x-coordinate of your vertex. So once I know my x-coordinate, we're going back to an input and an output, right? So we want to find the x value, now we want to find the y value. So what we're going to do is we're going to say f of opposite of b over 2a. And what that's doing is we're going to plug in our x value that we got and plug it into our function, and that's going to give us our output value. Because remember, the vertex lies on the graph, so therefore it has to be on the parabola if it's our vertex. So once we figure out your line of symmetry, that's your x value. Then you plug in your x value into your function to find the f of x. And I'll do a couple problems with these later. One quick thing though, I do want to show you our standard form, because sometimes you might encounter a parabola or a function in quadratic form, and you might want to either, it might be in standard form, or you might have to put it in standard form. I did many videos on completing the square. That's how the process of going from quadratic to standard form. But I quickly want to let you guys know of another form that we have, which is called our standard form. Now, if I was to distribute my a and square my x minus h, well, first I'd have to square my x minus h, then I'd distribute my a, I would eventually get back to a quadratic form. Now, obviously, I'm dealing with h and k's here, different than b's and c's, but the reason why is because they mean different things. If something's in standard form, it's very easy for me to find my vertex. My vertex is just going to be h, k. So therefore my axis of symmetry is when x equals h. And I'm sorry, my axis of symmetry here is when x equals opposite of b over 2a. So that's just kind of a quick overview of parabolas. I am going to do a lot of problems in the book, so just make sure you guys stay tuned. But pretty much that is really everything I wanted to make sure. As far as the a opens up or down, that's the same thing if it's in standard form. And that's really all I wanted to cover with you guys for my notes for overview of parabolas or quadratic functions.